Hello, my name is Yufeng Chen. I'm from the University of British Columbia. Today, I'm going to talk about NodeSRT, a selective regression testing tool for Node.js application. As software system matures, the cost of running entire regression test suite can become significant. Selective regression testing is a technique that runs only a subset of tests, so the regression test suite can detect software failures more efficiently. Previous study mainly focused on standard desktop applications. Node.js applications are considered hard to perform test reduction because of Node's asynchronous, event-driven programming model, and JavaScript is a dynamic programming language. In this paper, we present NodeSRT, a selective regression testing tool for Node.js application. We evaluated our technique with current industry standard SRT technique Jest OnlyChange. The results show that our tool is 2.5 times faster and 4.5 times more precise. Generally, there are two phases involved in SRT, test selection phase and test running phase. Test selection phase select tests based on dependencies and change. Test running phase executes selected tests. SRT selection operates at four levels of granularity: statement level, method level, file level, and module level. The most common two are method level and file level. File level granularity builds a relationship between tests and files, and select tests reflected on the changed files. Since method level selection is more complicated than file level selection, file level selection runs faster in phase 1. But file level selection selects more tests than needed, so it's less precise than method level selection, so it's slower in phase 2. To evaluate SRT's technique, Rosenmel proposed four metrics: inclusiveness, precision, efficiency, and granularity. Inclusiveness measures the extent to which SRT technique chooses tests that are affected by the change. Precision measures the ability that SRT technique omits tests that are not affected by the change. Efficiency measures the time and space required, and granularity measures the ability to function in a comprehensive and practical range of situations. The industry standard SRT technique for Node.js application Jest OnlyChange run test selection on file level. It builds a file dependency map with Jest HistMap module, so it is fast, lightweighted, but not precise enough. Now, let's take a closer look to our approach. Our intuition for reducing the total running time is to improve the granularity of test selection technique to improve precision, so fewer tests are required to run on phase 2. Given a codebase and a diff file, our tool uses a combination of static and dynamic analysis to generate a file dependency graph and a call graph. Then we perform a modification-based test selection which analyzes modified code entities, then select tests based on modifications. The change analysis module compares the ASTs of the change files, then generate a list of changes. If a function is anonymous, NodeSRT generates a unique name for it based on its parent function name, class name, and file name. With call graph and a list of changes, test selector can select tests. To handle changes outside the function, the test selector selects tests that depends on the changed file based on file dependency graph to make sure each changes is included. Finally, the test runner can run selected tests. Our empirical evaluations are performed on two open-source Node.js projects, Uppy and Simorgh. We chose these two projects because we require the system must be well-maintained and have a reasonable number of tests. We performed test selection on a total of 500 commits from the two projects. For each commit, we generate a diff patch from the previous commit to serving as an input. As we can see on the table, both Jest and NodeSRT select fewer tests than retest-all strategy. NodeSRT select even fewer tests than Jest as we predicted. For Uppy, our tool selects 1.5 times fewer tests. For Simorgh, our tool selects 5.3 times fewer tests. In terms of total running time, they both took less time comparing to retest-all. But for Uppy, although our tool selects fewer tests, Jest run faster on average. This is because Jest makes use of its own Jest HistMap module and customized file system, Watchman. Future work can be done for NodeSRT on this part. But for projects with higher code coverage, Simorgh, our tool took only 8.1% of the retest-all time, and it is 2.7 times faster than Jest. Okay, that's it for my presentation. Thank you for listening.